This is the Trig quiz review. We have 7 problems to do. First problem, name the quadrant in which the angle theta lies. Secant is less than 0 and cosecant is greater than 0. So we're going to reference the chart we made in your notes. If you don't have that, here's what it looks like. In this first quadrant, sine, cosine, and tangent are all positive. That's quadrant 1. In the second one, quadrant 2, sine is positive, but the other two are negative. In the third quadrant, tangent's positive, but the other two are negative. And in the fourth quadrant, cosine's positive and the other two are negative. Again, that should be in your note page. So if you want to look at that, it would be on your 4.3 notes. All right, so we don't have a separate chart for cosecant, secant, and cotangent, but I know secant follows all the same rules as cosine. And less than 0 means those are negative numbers. Cosecant follows the same rules as sine, which means I have sine is positive. And so I want to look for when that happens. So now that we've identified, we go to our chart and try to figure out which quadrant that's in. This happens, cosine negative and sine positive, in quadrant 2. All right, problem number 2, we're supposed to find the x in the right triangle. So we have x here in the corner, which means 47 is the adjacent, and 58 is the hypotenuse. So then we'll need to set this up using cosine. Cosine is the one that uses a and h. So we'll do the cosine of x degrees equals 47 over 58. And you can go ahead and type that into your calculator by doing the inverse. And then find your answer. So as we type this into our calculator, remember the first thing you need to do is change it to degree mode. So scroll down to the third line, fourth line on this calculator and go over to degree. Make sure that's highlighted right here and hit enter. And you can see it even changes at the top there. All right, so now you can see you're in degree mode and you're going to type in secant cosine. Make sure it says cosine to the -1 for this one. 47 over 58. Close that, enter, and there's our answer. It says round to the nearest tenths place, so we'll call that 35.9. Right, third problem, find the value of sine. All of our sides here are already completed for us, so all we have to do is label. This one's O, A, and H. Sine, which remember is O over H, is going to be 7 over the square root of 53. We have to rationalize the denominator. So we're going to multiply by the square root of 53 over the square root of 53, getting us 7 square root of 53 over 53 for our final answer. All right, problem number 4, find the exact value of cosecant if secant is 5/3 and tangent is 4/3. All right, so we'll have to label secant is H over A. Tangent is O over A. And I have all 3 of my sides there, O, A, and H labeled. So I can go directly into the problem cosecant. Cosecant, remember, is H over A. Sorry, that's not right. H over O. And so our final answer would be 5 over 4. The next problem, number 5, find the exact value of cosine. We do have a missing side here, so we'll need to use Pythagorean theorem. I'm going to label my 17 as the hypotenuse, 14 as the opposite, and this side will be my adjacent. Even though I don't have anything there, I still want to label the adjacent because I'll need to find all 3 sides in order to do cosine. Right, so I'll do a squared plus b squared equals c squared. Remember that the hypotenuse must be the c. And then take your calculator, do 17 times 17 and 14 times 14. 17 squared, or 14 squared would get us 196. 17 squared gets us 289. Subtract 196. Gets 93, and then we square root it. Thankfully, we don't have to simplify this square root, so we'll just leave it as the square root of 93. Then our answer for cosine. Cosine is A over H. Problem 6. For the point -5, 12, find the exact value of tangent. So we need to figure out which quadrant this is in. -5 in the x direction would be left. Positive 12 in the y direction would be up. That would make this quadrant 2. So I'll draw our triangle in quadrant 2. You go left, you go up, and back to the center. -5, positive 12. There's the theta. This is another problem where we'll need to find the missing side. So I'm going to label opposite, adjacent, hypotenuse, and a squared plus b squared equals c squared. Let's plug these numbers in. I am missing my hypotenuse, so I'm going to leave the c as my unknown. Finish this problem up. 144 plus 25 equals c squared. Add those. Square root to get a perfect square, 13. Remember, your hypotenuse can never be negative, so we write that as a positive 13. Then once everything's set up, we'll find our answer for tangent. All right, tangent, which is O over A, will end up being 12 over -5, O over A. Right, our last one, problem number 7. Cosine of theta is square root of 5 over 4, and your angle theta is in quadrant 4. Find tangent. So we'll start by drawing our angle in quadrant 4. Opposite, adjacent, hypotenuse. And then we'll put our labels on for cosine. Cosine we know is A over H. So this is the square root of 5 on the A. 4 is the H, and we are missing this O, so again, Pythagorean theorem. For the square root of 5 squared, the square root and square cancel because they are opposites. Just leaving you a 5, and then 4 squared is 16. Subtract 5 and square root. Square root 11 would give you a decimal, so we want to leave it as the square root of 11. And one thing to notice here, this is an invisible negative. Notice anytime you go down or left, you have to have an invisible negative. So it's a negative that shows up, but only on the triangle. Negative square root of 11. All right, once everything is labeled on the triangle, then you're ready to find your final answer. This is asking for tangent. Tangent of theta equals O over A. O over A. We'll have to rationalize the denominator. Multiply by square root of 5 over square root of 5. Denominator turns to a regular 5. And up at the top, since both of those are inside the square root bar, we can multiply them together. 11 times 5, square root of 55, bring over the negative. Here's our final answer.